Hello, calculus scholars. Um, we are going to today just extend a little bit about finding our limits graphically, and we're going to be opening a skill today where we're going to be doing limits graphically with properties of limits. So let me share my screen here right now. And we're just going to kind of go through some basic properties of limits. All right, so we're just going to say that suppose that the limit of a function that's called f of x is equal to a number called L. L could be a number like 5, it could be 3.14. And then we have a limit of a similar, maybe a different function called g of x, and that is equal to m, which is another number. So the addition property here says, let's say that I'm evaluating the two limits. So I have f of x and g of x. And I want to know what the limit is of f of x plus g of x. And we're assuming that the x value in which we are evaluating things is going to be the same. So I'm just going to circle that here. And I have that the limit, this is the same thing as actually doing the limit separately. So I could say that the limit as x approaches a of f of x plus the limit as x approaches a of g of x. So it's like I do the limit separately, and I would just add the two numbers that I got. So it would be L plus M. And then the subtraction, again, limits kind of share, that same, subtraction property of numbers and of algebra, that we had. So it doesn't matter if I, subtract the two functions and then take the limit, or if I just do limits of the separate functions and just subtract them. So like I do limit as x approaches a of f of x minus limit of x approaches a of g of x. And that would be L minus M. And if I have like a rational type of situation here, what's going on here? I could actually just do the limit separately and then divide. I have like limit of x approaches a of f of x over the limit of x approaches a of g of x. And that would be equal to L over M. And we can also do multiplication with limits as well. So if you are good at looking at individual graphs, what I will be giving you is maybe graphs of two different functions, and you just kind of separate them into two limit graphically problems and just perform the operation. So for multiplication here, we get L times M. A constant, you can always move the constant in front of the limit. And this would just be C times L. So you can just get that constant in front before you worry about finding the limits. There is one caveat here. Your limit of x, so this denominator in the division, your denominator cannot equal to 0. Otherwise, feel free to use all those additions and subtractions and divisions and multiplications that you did in like number and algebra world, but this time with limits. Okay, so next we are going to look at the application of an exponent. So what's going on here, just kind of a reminder here. The limit of f of x is L, and the limit of g of x is M. But just kind of a reminder with this one. If we have an exponent, we could actually just take the limit first. We could do limit of x approaches a of f of x and take that to the p power. So this would be the number L to the p. And then the last one, the limit of a constant function, it's always going to have that y value. It's continuous. That would just be your constant itself. So that's probably one of my favorite limits. It's kind of like that identity property, so to speak. So let's go to Delta Math now and actually look at a few examples. So let me get back to screen sharing here. So it says, given the following graphs of f of x and g of x, find the value of limit of x approaches -1 of f of x over g of x. All right, so here's what we are going to do. So we're going to first look at the graph of f of x. And I'm just going to use my annotate tool here. So here's f of x, and here is -1. And what I notice is it is nice and continuous. So I would just say that this, I'm actually just going to break this into the two separate limits. So I have the limit of x approaches -1 of f of x over the limit of x approaches -1 of g of x. So I get, for my f of x1, I get 6. And then I'm just going to go to my graph of g and find out what that limit is going to be. I'm just going to go down a little bit. And what I notice here is I look at that white circle. So like just a little bit below -1 and a little bit above -1. That's going to be about 1. Let me just get back down to the annotate here. So I'm just going to put in that value that I found from that graph. And lo and behold, we are done. So let's see how this works. So the answer should be 6. And what is nice about, like, if you are showing this work for like a pencil and paper mastery assessment, some people may do this like right in your head. I wouldn't. I would just kind of write down the property that you're thinking first, and then that will kind of show me how you got to